All right. Welcome, everybody, to the first Ceph Tech Talk of 2017. I know it's been a while since we've actually had a Blue Jeans Tech Talk. There have been a few canceled and a couple of in-persons, but nothing that has been globally reachable. So I'm definitely happy to be back. I'm assuming that most of you have seen the new Ceph.com if you made it this far, but if not, definitely go check it out. We've got all of the videos, and the video channel is featured heavily on some of those pages, including all of our historic Ceph Tech Talks, which you can find from the Ceph Tech Talks page or some of the various video pages there. So if you're interested in finding out what has come before us, definitely go check it out. But this week, we're going to be focused on getting started with Ceph development. So those of you that are old hands at Ceph development and have decided to join us anyway, definitely feel free to use the Q&A period at the end of the call here to perhaps suggest ways in which we could better onboard new folks or changes to the process that may improve things from your point of view, and we can have a little chat about that. But for the now, Sage is going to discuss how to do things like clone the repository, build, run via vstart, make changes, tests, push branches, submit pull requests, all of the good things that you need to know to become another old hand Ceph developer going forward. So without further ado, Sage, you want to take it away?
All right, thanks. Right, so I'm gonna do a walkthrough of a whole bunch of stuff, checking out the code, building it, fixing a bug from the tracker, testing it, making sure the tests run, pushing it, doing a pull request, and testing it, and then show you a bunch of other random stuff that I think will hopefully make it a little bit easier to dive in and get started. So I will start by showing off the new Ceph.com, if I can figure out the right window to share. You guys see that okay? So new Ceph.com, yep. There's a code section that has all sorts of useful stuff for people who are actually going to develop. First and foremost, it links to Ceph on GitHub, which is where all of our stuff is. Ceph is the main project, which has all of our source code. So this is the place to go. If you're not already a GitHub user, then you should just go sign up. You probably already are, though. If you're new to Ceph, then the first thing you want to do is fork the repository. So you go here to the Ceph repo and click fork. And I have to pick which account you're going to fork it to. In this case, I already have it forked, so it's not really going to do anything. But assuming that I did do that, it would tell me to wait a minute, and then it would, under my account, you'd see you have your own copy of the repository, and so on. There's a bunch of other sort of preliminary GitHub stuff that you'll need to do, like set up your SSH keys so that when you are doing, you can push and pull from GitHub. I'll assume that you've sorted that out since it's not really specific to Ceph. So assuming you've done that, you've cloned the code, then you're sort of ready to get started. I think the first thing we're going to do is I'm going to show you the bug tracker, and we're going to pick out a bug that I sort of identified beforehand as one that's pretty easy to fix, that I'm not too nervous about doing on video. So click through to the tracker and click on issues. There are lots of open tickets here. We mostly use Tracker for bugs. There are a lot of feature tickets in here too, but it's sort of more geared towards the bug tracking. The feature stuff is a little bit more ad hoc. On the right side, you'll see that there are a whole bunch of sort of predefined queries that are useful if you're doing development. The most useful for me are the bug queue, which basically takes all the bugs in all the projects and sorts them by priority. So immediate are all the ones that are like causing QA failures right now and sort of are the most highest priority, and then sort of goes down from there. The one I'm going to pick out is one that came in a couple days ago here. Somebody was trying out BlueStore on Kraken, and they were testing it out on some small disks, and they filled it up, and BlueStore wouldn't start, and that's not supposed to happen. So I already looked at this, so I already sort of know what the problem is. It turns out that the root issue is that BlueStore wasn't was reporting all this space that is reserved for metadata as free. And so in this case, it sort of misdeployed it. So they had a ton of space allocated to metadata and not very much to data. And so Ceph didn't realize that the OSD was basically full. And so it was let it basically get all the way to full without stopping it. Whereas normally Ceph will prevent you from doing that. And that led to this crash. And when it tries to start up, it tries to do some internal writes and it fails because there's no space. So this is the bug that we're gonna try to fix. So the first thing you want to do is make sure you check out the Git repository. So I'm going to switch which window I'm sharing here. If I can find it, I think it's this one. Can you guys see that? Let me know if the font is too small or whatever.
Looks good.
All right, so first thing you want to do is clone the repository. If you've used GitHub before, if you have your account SSH set up, this is the syntax you use. I usually clone the master Ceph repository and then add my own repository as a separate remote. So we'll go ahead and do that. This takes not too long, but it'll take a little bit because it's a pretty big repository. In this case, I already did it in another directory, so we don't have to wait for it. So this is the repository I cloned and checked out for all the files. You'll notice that origin is the master one. Usually you'll want to do something like git remote add, and then add the remote for your actual clone of the repository. That's how I manage it. Doesn't matter too much how you do this. So that way I can push branches to either my clone or to the master clone. I suppose actually for a normal contributor, they're never going to be pushing to the master one. They're only going to be pulling from there. But either way, you're going to want both remotes in your Git repo so you can interact with both of them. So the first thing you usually want to do is make sure you have all the build dependencies installed. There's this handy dandy script called install deps that will do that. So you just need to run that with sudo. And all this actually does is it looks through it decides what distro you're on, and then it looks through the packaging files and looks at all the build dependencies that the package files have for that particular distro, and then it installs everything. So as long as we have our packaging stuff up to date and it's working, then this should always install all the things that are necessary for you to compile and build Ceph. So in this case, this is a Fedora box. It's going to go download all these packages. In reality, there's nothing to do because I've already run Ceph on here before, obviously, and I have the dependencies. It also sets up some virtual environments, Python stuff for something. Actually, I'm not actually sure what that's for. But it'll give you everything that you need in order to get going. The next step then is to, I'm just going to cancel because we don't actually just finish that. The next thing you want to do is set up, get the repository ready to build. There's another handy dandy script in here called do CMake. CMake is the build system that we use for Ceph. And this one you run without sudo. You just run it. It does a bunch of stuff. Mostly it makes sure that all of the Git submodules are initialized recursively. Turns out we have a whole bunch of these. So this step is actually going to take like 5 minutes. And then it creates a build directory and runs CMake to initialize all the build stuff. And then it does this one last thing with setport that I'll talk about in a little bit. But anyway, you run do CMake. It's going to check out all these submodules. This takes a long time, so I did it ahead of time in another window. But the first time it'll typically take about 5 minutes. That's fine. Thereafter, for this checkout, it won't take that long. It's just sort of getting the thing set up the first time is sort of expensive. In this window, I've already run that do CMake script. This is all the stuff that it did finished up, and it says it's done. So we're all set. So you can go into the build directory, and at this point, you have a working build environment, and you can type make to build the whole thing. That'll start compiling a bunch of files. That also takes a long time because Ceph is a pretty big project at this point, and the C++ compilers aren't super fast. So on my box has like 32 cores. It takes somewhere between maybe 5 or 10 minutes. I'm not really sure. It takes a while. So I also did that ahead of time in another window, so we wouldn't have to wait for it. And once the compile finishes, it'll get up to 100% and you're done. Yay, you've compiled Ceph. That's sort of first step.
Do you have a rough idea of how much space that takes, Sage?
Let's see. The build directory is 20 gigs. Overall, the checkout plus the build directory is 22 gigs. So it's quite a bit of space. One thing that's kind of nice about CMake, it builds sort of out of tree. So this, we call this directory build by convention, but it can be whatever you want. You don't have to run it in here. And you can just delete this directory and rerun CMake and have a completely fresh build without actually affecting the rest of the source code, which is in the source directory mostly. So maybe I'll do a really quick tour of the source tree before we get too far. So build, this isn't actually part of the Git checkout. That's just what I created for CMake. There's some submodules here, CMake files, Debian packaging files. Doc is relatively big. This is all of the RST files that are used to generate docs.ceph.com. They're all managed in Git, and when we merge something to master in Git, there's some Jenkins job that actually goes and rebuilds the docs and updates the web page automatically. And that page also can be updated, can be viewed for any branch within the repository. So you can go and view the Hammer version of the docs or whatever. So documentation contributions are also extremely welcome, and they're also just managed through Git and GitHub. Let's see examples. There's some random stuff in here that's not super important. Keys has the PGP keys that are used to sign releases. So they're there just so that they're well publicized. There's some scripts here that are used to for packaging. Make dist generates a sort of official tarball of the source tree that's then used to generate downstream packages for distros, RPMs, and debs. Some man pages. The QA directory has all of our test stuff. So it's a kind of a mix of stuff. A lot of these scripts are just scripts that you can sort of run standalone. The work units directory is scripts that you sort of run on an existing cluster. And then the suites directory is all the YAML files that comprise our big QA suite that we run automatically on everything. So all that stuff is also managed here in Git. But the most important bit is really the source directory. This is where all the source code is. So we'll go there. This bigger. So there's some architecture stuff, authentication, yeah, a bunch of random pieces here. There's an include and common directory. These directories have shared code. There's directory for the MDS, for the monitor, for the OSD, sort of the client side of the OSD, and Liberatos are here. That's all sort of all over the place, but it's not too confusing. It's not the most tidy organization of code because it's sort of an old code base. We've never gone back and really sort of reorganized. For example, the separation between common and include, it's all sort of common stuff and it's sort of arbitrary what's where. But it's not too bad. So yeah, right. So that's the tree. So you'll recall that we're gonna fix a bug. It's hard to fix a bug without actually being able to run the system. And one of the nice things about building all the stuff from source is that we have a collection of scripts that make it really easy to run sort of toy clusters directly out of the source directory via a script called vstart. So I'll show you that now just because, so in this particular checkout, I've already done a build and once I'm inside this build directory, then you can run vstart, which is back in the source directory. So normally you run this with a couple different options. That one you don't need anymore. And I'm just so used to typing these that I type them mostly without thinking. So -D means it enables all the debugging. So it cranks all the debug levels on the daemons to very high levels. And so when you're running this little test cluster and something goes wrong or you're debugging, you can just go look at the logs. It's all there. N means that when you run the script, it's going to create a new cluster. There's a way to run this script where you'll rerun it on an existing config and but it's not very well tested or supported. I actually don't think anybody uses that, so we'll probably remove that in the future. And -L just means that it's going to bind to localhost to 127.0.0.1. By default, it looks in your Etsy hosts and tries to figure out what your host name is and then figure out what your IP is so that this toy cluster can be accessed from a different machine. In practice, no, hardly anyone really needs that, so I usually just patch -L. That's also helpful if you're like on a laptop and your IP is changing all the time anyway. So anyway, you do that, you'll see a pile of stuff go by on the screen. It'll take just a minute for this to do. By default, it starts up a tiny cluster with 3 monitors, 3 OSDs, and 3 MDSs. And very soon now, it's also going to start up one of the Ceph manager processes. But the important bit here is that it ran. You see started, dun, 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 it's running. There's a directory called out that has all the logs and the socket files. So you can look at what the cluster is doing.
Sage, I'm not sure why exactly, but your terminal is really lagging your discussion here.
Oh, really? Okay.
We're just seeing the entry of the vstart command at the moment.
Weird.
There it is.
Okay. Okay. That's unfortunate. I'm not sure if there's a way for me to fix that.
It looked okay for me. You were on sync for me, so I'm not sure if other people are experiencing lags.
Yeah, Dan, that might just be.
Okay. We'll hope it's just Dan. Okay. So right, the cluster is running. The out directory has all of the log files. There's a dev directory that has all the actual data. So all the monitors are rooted in these little mon directories. If you look in there, you'll see, they have their RocksDB backend and all the rest. On the OSD directories have all the files. So you basically have this entire cluster running in this directory. Because I'm in the CMake build directory, the way that CMake builds, it puts things in bin and lib and so on off of that subdirectory, so I can run, and that vstart script creates a ceph.conf in the current directory. So it's set up so that I can just run commands as long as I give the partial path there on that cluster. So I can do ceph-s. There's this annoying little warning that tells me that it detected that I'm running out of a source tree and it's kludging my path and Python path and all this other stuff that sort of annoying, but is nice that it does all that for you. But yeah, the Ceph cluster is there. It works. I can see the OSDs are up. The monitors are up. The OSDs are up. I can run whatever Ceph commands I want. Here's my OSD. They're all on this local host. I can interact with it. I can tail the log. And so on. So I can run Rados, bench, RBD. Can write data to it, all the good stuff. So it's, for all intents and purposes, it's a fully functioning cluster that you can test and manipulate. So that's good. When I'm done with it, there are a couple other ways you can interact with this vstart cluster. There is an init ceph script. This is actually the system5 init script, sysc init script that's normally etc init.dceph that's installed on old distros. But it's also usable from this vstart environment. So I can do stop oc.0 and it'll stop that one daemon. And then ceph oc3, I'll see that it's stopped. I can start it again. I can stop the whole cluster, start the whole cluster, all that stuff. So it's reasonably easy to interact and sort of do all the things that you would normally do with sort of a real install out of your source tree, which is kind of nice. The one other thing that I'll mention is that there's a sort of a magic Ceph port file here that has a random number in it. The do CMake script that we ran at the beginning generates that file with a random value between 1,000 and 4,000. And the idea here is that when I run this vstart cluster, it will put the monitors on that port. So if I have multiple Ceph checkouts, they'll generally be operating on different ports, and so I can run these vstart clusters in parallel on different checkouts without them stepping on each other. Probably, because it's just using a random number, so most likely it won't collide, but whatever. So that makes it slightly more pleasant to deal with. Okay, so sort of back to our task at hand, we're going to fix this sort of trivialish bug in BlueStore. So the first thing we probably want to do is make sure that our vstart cluster actually is set up with BlueStore, because by default it uses file store still. So I'm running this stop script to shut everything down, stopping all the daemons. Takes a second. Right, you'll notice that these are file store directories. They have this current directory, and they layer all the files on top of all the objects on top of files. So we can run vstart again. This time I'll pass the -- BlueStore flag, and that's just a hacky thing in the vstart script that makes sure that the OSDs are initialized using vstore. Actually, I'm going to do something else too here. Mention one other thing. There's also a stop script that pairs with vstart that just does a kill all. That just kills any Ceph daemons that are running. So if it's behaving weirdly, you can always run that. vstart also takes some environment variables that let you specify how big of a cluster you can make. So in this case, I want to do some work on an OSD. I don't really need 3 monitors. I only need one of them. I only need one OSD. I don't need any MDSs. So I can specify this in front of vstart. And then when I run it, it'll create a smaller cluster. It's faster to run. It's a little bit easier to set up. So depending on what you're working on, you'll want to do that. By default, it does 3 mods, 3 OSDs, and 3 MDSs, just so you're generally exercising all the load balancing and distribution code. But for this sort of specific case, I can start up a small one.
Sage, are the options and flags and things for all of this stuff enumerated somewhere?
Barely. So vstart is a developer script, and so if you look in the script, you can kind of see all the stuff that it pulls in. It has a usage actually in here that's not fully complete. So yeah, it's not super well documented. Just sort of one of the things, I guess if you do vstart if you do -h, you can see all the stuff it supports. Although this doesn't document those things that specify how many to start up, and some of it's out of date. This is a really old script. Recommendation is that we need to do some cleanup, but also we sort of document the well used options, because the other stuff might change. Okay, so we have an OSD running now, and it turns out that the core issue is that with this particular bug is that BlueStore is misreporting the amount of space as available to store objects. So if you do Ceph OSD df, this tells you what the OSD is reporting. It says it's 10 gigs and it's used, and it has used 10 megs of it, and it has this much available. In reality, what vstart is doing is it's actually just creating a big file that is the quote unquote block device. And BlueStore, as far as BlueStore knows, this is its disk. So in this case, it's 10 gigs is the default. There's an option that you can pass to vstart or put in your Ceph conf that'll specify how big those sort of fake devices are, but that's big enough for most testing. But in reality, BlueStore is taking a chunk of that, and it's using it for space for RoxyDB for its internal metadata, and it's reporting that as free space. And so Ceph thinks it can store objects in that space, and it will start sending objects to that OSD when in practice it really shouldn't. So the key thing here is that it's reporting that there are 10.293 gigs available, and it shouldn't do that. So let's fix it. So I'm gonna Emacs, and I'll have to switch my sharing around here. 1 second. All right, can you guys see that okay?
Yes.
All right. So I'm gonna load up the main BlueStore source code. It's in this OS directory, which is short for object store. Ceph abstracts the sort of backend storage from implementations. There's file store, which stores on files, BlueStore, which is the new one. There's a mem store that stores everything in memory, and there's a K-store that's an experimental thing that just puts everything in a database. But in this case, BlueStore is here, loaded up, and it turns out that the bug is in the statfs call, which is the function that Ceph calls to ask BlueStore how much space is available. And the bug, I believe, is that if you're using BlueFS, which you basically always are, this is sort of the subset of BlueStore that allows it to embed RoxyDB on the same block device. It adds in this free space that BlueFS has as available space. So this first part is mostly fine because if the OC starts to fill up, we can claw that space back from BlueFS. But the second part, there's a second, you can set up BlueStore so that there's a second device that's like dedicated just for metadata. So if you have lots of extra SSD, you can just sort of put RocksDB there as long as there's room. And right now, BlueStore is reporting that as free space too, but that space can never be used for object storage. It's only usable for metadata. And so the fix for this particular bug is to not report that as free space. So I'm going to change it so that it doesn't call it available, but it does sort of add it into the total because you are still, that space still is part of the cluster in some sense. It's just like fixed overhead. So I'll just delete that line. And that's it. So that's the change. We've quote unquote fixed our bug. But in practice, of course, the job has really just begun. There's a lot more to do than that. So if you do git diff, you'll see that eventually you'll see, why is this going really slow? You'll see that that line has been changed in Git. So the first thing we want to do is recompile to make sure that our change works. So you can run make again. That'll rebuild and relink everything, and it should just detect the things that are that have been changed. Sometimes you make a change that's actually like touches a header file and it'll force everything to recompile. Or if you actually do a git commit, it'll touch the file that embeds the Ceph version in every binary, and so it'll have to relink everything. And so sometimes you don't actually want to build everything. So there's a magic target called vstart that will make everything that is necessary to run a vstart cluster. So if you're doing development, that's often just shortens your build times by not building all the unit tests and everything else that you don't have to, that you're usually not or often not iterating on as much. So you'll notice it recompiled BlueStore, and if it gets in a moment here, it's going to get down to. I'm not sure why this box is going so slow right now. Or if you want, you can just do just Ceph OSD because I know exactly which binary has changed. So I'll do that too. So you'll recall that before, when we ran our cluster, the free space was reported as 10.289 megs, I believe. So we're going to compile this, and it will hopefully report that there is less available space. But it's slow. Why is it?
I'm talking about different CMake targets, Sage. I think there is also a make list or make list targets or something that will show you all the possible targets.
Be true. I'm not familiar with that. But yeah, if somebody wants to put it in Etherpad, if they know what it is, that would be great. Okay, so vstart has been recompiled. My Ceph cluster is still running. And remember, I can do Ceph OSDDF, and I can see that the old code, which is still running, is reporting that it has 10.293. I can just restart the OSD daemon. I'll kill the old one, restart the new one that I just recompiled, run Ceph OSDDF again, and it is showing the same amount of space. That's kind of weird. Did I misread that?
Sage, it did not get restarted properly. You got permission denied.
Oh, did I?
Just a little bit up. Where log subsystem stuff.
All right, that might have been something else. There are warnings there about like it tries to do a bunch of random stuff. It's ignoring this command since I'm not root. Starting. Should have started. I think it started. Okay, so it's 10.236 and it was 10.238 before. Is that right? I don't know. I don't know if I really fixed this bug. Let's assume for a moment that I correctly fixed this bug. Maybe I should have picked an easier one. So you can use vstart to test your change, make sure it actually behaves. You can interact with the cluster. You can, write some data and make sure it still works. Maybe in this case, I would actually try to fill up the my little toy cluster and make sure it hit space, and I could still restart the OSD, so on. But for now, let's assume that I did the right thing. So the next step is to test it. Let's see. So I've done my ad hoc test. The other thing that you can do is run all the unit tests. So for that, in order for that to happen, you'd run a full make to compile everything. We've already actually done that. So you can always just run make check. The problem with that is that it runs the tests in single threaded, I believe. And so a better way to do it is to use the ctest utility directly. This is part of the cmake suite, and is used to run all your unit tests. There are a lot of them, so I don't want to run them. If I just run ctest by itself, it's just going to run them one after the other. It's going to take forever. And so you can pass a -j just like you can with make. And it's going to run like, say, 12 or 16. In practice, if your level of parallelism is too high, if you go above 16, it tends to not work as well. You get sort of spurious failures. So I usually do 12 or 16. That seems to work pretty reliably. But this will go through and it'll run all these unit tests. So unit test underscore tend to be standalone files that test like a very narrow piece of code with a bunch of sort of crafted unit tests. There are a bunch of other tests that are bash scripts that do various things. They tend to, there's a whole category of them that actually set up these little vstart clusters in a sandbox and sort of run tests on a little miniature cluster to make sure that, so they're like small integration functional smoke tests, I guess. So there's those two. But this will go through and it'll run all those. We'll assume that it passes and that everything works. And so you're like, great, I've done my fix. I'm ready to commit. So the next step is to git add and git commit. For anyone familiar with Git, that shouldn't be too weird. The one thing I want to show or suggest everyone do, they always use Git GUI, because Git GUI is awesome. It makes it much easier to sort of manage the things you're committing and stage them into particular commits and write the commit message and so forth. So I skipped actually one thing. Right now I'm still in the master branch. I'm fixing some particular bug, so I want to actually switch into a branch that's like whip blue store statfs bug, whatever. So switch to a new branch before I commit. And then I'll do, I'll run Git GUI to actually do my commit. So I believe I have to reshare this. Hold on, Git GUI. Is that right? Can everybody see that? So the nice thing about Git GUI is that it lets you stage the changes for your commit. So these are all the, if you hit reload, it'll refresh. It'll show all the files up here that have modifications, and you can look at the diff. So this is the one I want to stage. So I just click on the icon. Now it's down here. It's actually going to be included in the commit, and I can write my commit message. So this is important because we want the Git history to be clean and reflect have all the right information, so we know what the change is, why it was made. It's easy to find and so forth. So the first thing is the first line should always be a short one-line description of what you did. And it should be prefixed with the subsystem. The convention here is to use the actual path names for whatever the subsystem is. So blue store is just stored in the OS blue store directory. So I'll prefix it that way. And I'll say fix statfs to not include db partition in free space. That's the short version. And then the long version is if we report the db space as available, Ceph thinks the OSD can store more data and will not mark the cluster as full as easily. And in reality, we can't actually store data in this space, only metadata. Avoid the problem by not reporting it as available, whatever. So you want to sort of explain what the problem is, what the impact is, what the fix is. And then the last thing you want to do is make sure you always add a signed off by line. And in Git GUI, you can just hit Control-S and it'll do it for you, which makes it easy. What this line means is that you understand what the open source license is, and you're submitting this code and attesting to the fact that it's being done in accordance with that license. So in Ceph's case, almost everything is LGPL, and this is just saying, I know it's LGPL, I'm submitting this under the LGPL license. So it's okay. You can read about this in more detail. At the top of the Git repository, there's a file called Submitting Patches, and it goes through what exactly this DCO sign-off, developer certificate of origin, what exactly it means, and how it's used. And that has to be on every single commit, or else we won't merge it. It'll be rejected. The last thing I want to do here is that this particular patch is fixing a bug, and so I want to reference that here. So back in the tracker, the ticket that we were solving was, let's see, 18599. So I'll just paste the URL for the tracker entry right there. And that's it. One thing to note, if you look at some older commits, they'll have lines that look like this, 18599, where it just references the bug by number. The problem is that GitHub also references things by number, but it has its different issue numbers. So this is a pull request or a GitHub issue. And if you say fixes this and you commit it, it thinks that you're talking about a pull request, and it'll actually go close that pull request if it happens to exist. So don't do that. Always just put the full tracker URL here, and that'll be better. And then hit commit. I've committed the change. You can go look at the history. So the other thing that you should be familiar with is Git K, if you're not already. Git K is just a GUI way to view the Git history. So it shows here that there was the master branch, was what I had checked out. I had a new branch, so I added one commit on top. Here it is. You can see the whole commit there. Git K makes it really easy to visualize the history. You can see merges and where they came from. You can browse. You can go look at a line here, and I can say, when was this line added? And it'll search back through the history to find the commit that added that. You can do all kinds of stuff here. That makes it really, really, really nice. So if you don't know already use this, I suggest you to, because it prevents you from getting lost. Yep. All right, so we've committed our change. The next step is to push it back to GitHub. So in this particular checkout, I haven't added the remote origin for my own Git clone, so I'll add that now. That's github.com, my GitHub username, and the repository name. So I can do git push me, and then whip bluestore statfs. Whenever you're doing push, I suggest you always specify which branch you're pushing, because there are certain versions of Git and variations of the push command that will try to push everything. And particularly when you have access to repositories that aren't just yours, you want to be very careful about sort of pushing random stuff. In my case, I can push to some of the, like the Ceph repository, and I never want to accidentally push something that I don't want to. So it's good practice to just always name the commit that you're pushing. It also just make sure that it does exactly what you want it to do and nothing more. So that's that. If you go look on GitHub, you'll now see that there's a branch on my particular GitHub with that particular change. So the next step, we've patched our bug, we've tested it, we've made the commit, we've pushed it, we've run some tests. The next step is to actually open a pull request so that on GitHub it shows up as being a request to merge code upstream. There are a couple ways to do this. Most people, I assume, use the web interface for GitHub. There's a link that you can click that says open pull request, and you specify which branch to merge from and where to merge it to. I never do that because you have to click through a bunch of web stuff. There's a command line utility that lets you do the same thing that I highly recommend everybody use if you're not already familiar with. It's called Hub. It's written by GitHub, not surprisingly, and it makes this whole thing much easier. So I will do that very briefly. You go to GitHub Hub releases. Well, it's under GitHub. It's under the GitHub account. The program is called Hub, and they have a page that has pre-built packages. So it's pretty easy to install. You can go down here, and if you're on whatever, I'm on Linux 64-bit, I can just download. I think this is just, I guess it's a tarball. I don't know. I can't remember. And you can install it. So in my case, I have it set up in my path on all the machines that I do development on. So my home machine and my laptop. So if you look in tilde-bin for my directory, I have this hub thing right here. So I can use it. And the idea of the command is that you can substitute it for Git. So if it doesn't understand the command that you're doing, it'll just run Git with the same arguments. I don't actually use it that way, but you could. I use it explicitly. But if you wanted to, you could actually alias Git to be this command. That's probably more confusing. In any case, if I want to create a pull request, I can do the hub pull request. I have to specify the base, which is the thing that I want to merge to. In this case, it's the Ceph user on GitHub and the master branch. And the head that I want to merge from is the Luigi's user, and my branch was with bluestore statfs. And I can run that command. Then you have to enter a description for the pull request. This will look the same. You want to prefix it with a subsystem and say fix statfs.
On the branch, because it should automatically populate this.
Yeah. Oh, I know. I mistyped it. That's what happened. Yeah. It normally. So yeah. So if it's a single commit, then it's actually just going to put it'll do this. It'll just put it in there for you, which is really nice. If it's more than one commit, then it'll show you a Git log basically in the down here in the commented out bits. And so you can sort of see what's going to be included, then you can write an appropriate description up here. The important thing though is to follow the same convention that you use for a Git commit. So always prefix it with a subsystem and have a short one-line description. The main reason for that is that this line is what appears in the Ceph release notes. There's a script that generates the release notes based on these pull request merge commits. So when you get a new release and you want a nice summary of what changed in that release, and you want it to be meaningful, you have to make sure that this actually means something. Most sort of new contributors don't. They just have they don't have the prefix and they don't do that. And so I have to go fix it up manually before merging the commit, and it just takes time. So please follow the convention there. And that's that. So I'll save it, and it'll go, and it'll give me a URL. That's the thing that it created, and I can go look at that. And I have to switch which window is being shared every time. It's sort of annoying. Right. So here's the pull request, and you'll see that it's merging to Ceph master from my branch. You can see what commits are there, just that one. And that's that. So sort of the next step is for all these proposed changes to get triaged and tagged. So in GitHub, we use these labels extensively to sort of identify what kind of change it is and what subsystem it affects. So in this case, this is a bluestore change and it's a bug fix. And I might tag it as core, which sort of refers to all the Rados stuff also. So I'd set those tags so that it's easy to sort of cross-reference and find later. If there's a particular person that should review this, then I can call out and say, I want, Igor to review this, say, and I can tag him explicitly. Or you can tag them offline, whatever. As a new contributor, you can't actually do all this stuff. So you have to be a member of the Ceph organization before you can add these tags. And you should be able to request reviews on your own code. So this should work. But the tags, somebody else will have to go through. So periodically, one of the maintainers actually goes through all the new pull requests and finds ones that aren't tagged and tags them and makes sure that they're referenced and so forth. But that would be the next step. We can sort of pretend that, okay, so a couple other things happen down here. It'll say review required. Before any code ever gets merged, it has to be reviewed. Only a small set of users can override that check, but they shouldn't. So hopefully Igor or someone will say, yes, this looks right. We also run a bunch of checks automatically. This one is sort of trivial. It just makes sure that every commit in the pull request has that signed off by line. And so that And if it doesn't, that'll fail and you won't be able to merge it. We'll have to go tell you to go fix your git commit messages. This one is just a safety check. Because Ceph has all these submodules, it's really easy in Git for the submodule to sort of get off on a different branch, a different commit if you are switching branches. And when that happens, it's easy to sort of accidentally commit that submodule change into a new commit when you're not thinking, which will usually like revert a change that somebody just made to a submodule. Not usually what you want to do. And so in the past, like half a dozen times, we've accidentally screwed up the submodules just because we didn't notice that some new commit changed it again. So this just goes through and makes sure that you're not touching any of the submodules. And if you do, then you notice and have to sort of override it. So that's all that is. It's just try to avoid user error. But the main thing that happens is this default check, and that actually runs make check. It runs that ctest-j16 or whatever thing that I mentioned that I showed you earlier. It does that off on some machine somewhere in a sandbox, and it'll take a while. And assuming that passes, then this little dot next to the pull request will change to a check, and then it'll be legal to merge. But right now it's still pending. So in these cases, all the checks passed, and this one it failed for some reason. And so the maintainer, I guess that's me, or the developer should go fix it. Yeah, so this is usually sort of the last step for a normal contributor to commit no code. I guess maybe the last step would be if this is a ticket, you can go update the ticket to say it's needs review, that there's actually a fix associated with it. Take the URL and paste it into the tracker, and so that the bug tracker reflects that there's a fix pending. It just needs to be reviewed and tested and so forth. Right. So that's the first part. So now I'm going to go through sort of the second half of the process that happens behind the scenes that not everyone participates in, but I think it's helpful for everyone to understand how it works. So what happens sort of at this stage is that hopefully someone will review the code and they'll say, yes, this is a good change. In this case, I can't review it because I wrote it. Maybe I can. Oh, I can't approve it though. I can review it, but I can't. Actually, it doesn't count for anything, which makes sense. But I could, if there was some other change, for example, that one's also mine, or something trivial. Oh, whatever. It's some other change here. I can go through, I can review the code. I say, yes, that looks right. And I can say approve. And in this case, on this one, John approved this, reviewed it. And so this comes up clean. There's probably a spurious error there. We'd have to resolve that. But assuming that also were a check mark, then they could technically go, GitHub would allow you to merge it. But in practice, we don't do that because we want all code that goes into the Ceph master branch to go through the QA suite before that happens. And so what typically happens is you, after you review it, you mark the issue needs QA. So it looks like John forgot to do that. So you go through and there's a label that says needs QA. You would add that. And if you go and look at all of the pull requests and filter by needs QA, you can see all of the new pull requests that have been submitted and have been reviewed and are ready for sort of the final QA gauntlet or whatever. And there are a whole bunch of them here. Usually someone will go behind the scenes and actually go run this QA manually. Yuri does a lot of it. He'll look at all the things that are tagged and he'll build a branch that combines them and run them through QA. Sometimes the maintainers do it or developers do it. Like I'll periodically batch up stuff that are in a particular area that I'm working on and run it through tests. And the way that works is, I would say, pick out a couple of pull requests that I want to test together. Say it's these two. And I would add a label that says these are in my whip stage testing branch. And I would add that label. So now that it's now somebody who's looking at the GitHub pull request can see what it is. And then I would go build a branch that includes these two pull requests. And that's actually pretty easy. If you go down here to the merge, there's a command line instructions, and there's this one line here that you can just cut and paste into your terminal, and it'll merge this particular pull request into your current branch. So let me switch back to my terminal. I'll do is I'll check out the master branch, make sure I'm on the latest. Branch -b, I'll create a whip stage testing branch. Check out -b, whip stage testing. And then I'll just paste these lines in here. So I'll merge that first one in. And then the second one, I'll merge the second one in. And then I will do a make, and I'll make a ctest-j16 to make sure it passes unit tests. And assuming all of that works, then I'm going to push my testing branch to this CI remote, which I haven't actually set up yet. Git remote add CI git at github.com Ceph CI. So we have a special clone of the Ceph repository and the GitHub account that's used just for CI. And it's magic in that any branch that you push to that repository gets automatically built and generates packages that show up within our sort of build system. And so in this case, I build this integration branch, I want to go test it. And so I would run make and ctest-j. I'm just going to pretend for a moment that those work, because I don't want to wait for them for the purposes of this demo. And I'll push that branch. That means that I can go look at our build environment, our build system, which is called Shaman, and it is going to go build packages for that branch. It'll take a little bit for it to show up here because Jenkins has to notice the branch appear and find a free worker and everything. But you can see here there are a whole bunch of other branches that people have pushed and that we've built packages for. So it of course builds all the main branches that are in the ceph.git repository, so master and Joule and Kraken and all those. And then also will build all the stuff in the Ceph CI, like all these whip branches. So an example of that would be, there was a branch that I pushed earlier today. Scrub waitlist was a fix I pushed earlier this morning. This is the git commit, and you can click to see all the repositories that have been built for this. Looks like it's built the Xenial and Trusty packages, but it hasn't built CentOS yet. They failed. This doesn't normally happen. I don't know. Either I have a bug or the build system is broken. I suppose I should have checked this before.
Nah, demonstrate the pain.
Yeah. So normally these all show up green after, usually takes about an hour and a half for it to go through the system and get a packages come out the other end. So in this case, installed but unpackaged files found. Oh, so there was a recent merge into master that changed the packaging and it broke the RPM package generation. So probably all the pull requests based on a recent master are failing in the same way. So hopefully somebody's noticed that and they're going to go fix it. So we won't look at that for the purposes of this test then. But we can look at an earlier branch. Yeah, see here, just notice whip stage testing is going to go build that. It's probably also going to fail. But some of these earlier ones here are fine. Like this branch I pushed last night, it looks like, and it built all the repositories for all three distros. So in our test lab, we have CentOS 7 machines, we have Ubuntu 14.04 and Ubuntu 16.04 machines. And we do two variants of every build. If you look carefully at the bottom of the URL for these is slightly different. One of them is default and one of them is no tcmalloc here. So we build a variant of the packages that don't link against tcmalloc. And the only reason to do that is because a lot of our QA tests run Valgrind to do like leak checking, memory leak checking, and that doesn't work with tcmalloc. And I think there's another conflict too. There's one other reason why we needed these packages. So for those tests, it installs these different packages so that the automatic memory leak checking stuff works. Right. So you've built a test branch, you pushed it, packages have been built. Now you actually want to run it through some QA. And this is all done through a tool called Teuthology, which is the study of cephalopods. It's hosted on GitHub, and there's a whole group of people here that maintain it. Mostly Zach is sort of the lead developer here. And we have a big installation of this in the community test lab that we use to run all the QA before we merge things into master. That test lab is called Ceph, and there's actually a Git repo that has somewhat outdated information about the test lab for the Ceph project. It generates this web page. So this is probably like 10 racks of gear that's in the, it's hosted in a data center, some data center space that Red Hat provides, but it's not at all specific to Red Hat. It's for use by the general community. Lots of gear. Some of it's owned by Red Hat. Some of it's owned by other people. A lot of it's been donated. There's sort of a lot of core machines that are used for a lot of the main testing. There's a bunch of really old gear that we got from DreamHost that we run some internal Ceph clusters on that host all the QA infrastructure. So we're sort of dogfooding there. And then there's a whole bunch of random hardware that people have contributed for testing various things. Like there's a bunch of odds and ends ARM hardware, some high-end performance gear that came from Intel that we use for some of the performance testing, all kinds of stuff. This page attempts to catalog it, but this is actually really out of date. So actually a slightly better place to look is one of our other tools called Pulpito, which is used to look at all the test results. There's a part of it that lets you see all the nodes in the cluster. So the main ones that we use for testing are Smithy. These are like 1U machines with NVMe cards. There are like 200 of them, and they're what run the bulk of the bare metal testing. And there are a bunch of Mira nodes that are these ancient 2U boxes that we use for internal long-running cluster and for running tests. So the Ceph test lab is available for use for any active contributor to Ceph. So if you are doing active development, you've merged code, and you're sort of involved in the developer community, then you can and should request access to it. So you can use the shared resource. And the way to do that is on the Ceph webpage, there's a link about requesting lab access. You basically set up some SSH keys and a VPN key, and you file a ticket asking us to give you access. And once you do that, you'll be able to log into the lab and use the shared resources. Until that point, then you'll have to rely on other developers to run the tests and do that integration stuff for you, which is usually fine. It's more efficient that way anyway. But if you're doing extensive work, then you should get access to the lab because it's pretty valuable. Okay, so we use a tool called Teuthology to run all these tests. It's another Git repository. It's all written in Python, and you can set it up on your machine. Although in practice, it relies on sort of the lab infrastructure to actually schedule work. And so the way that most people use it is they get an account on sort of the master node in the Ceph lab and install it there, and then they run it to schedule jobs on the cluster. So I'll show you how that works. I'll switch back to my terminal. So Teuthology.ceph.com is the main machine. And eventually this will log me in. In my source directory, I have a checkout of Teuthology here. Setting up Teuthology isn't too bad. You basically want to you clone it like you normally would anything else. Teuthology.git, whatever. And then you would, once you have the checkout, there's a script called Bootstrap that'll set up a virtual environment and pull in the Python dependencies so you can actually run it. And that creates a virtual env directory that has the binaries that actually all the little bits and pieces. Most of the commands are Teuthology - something. all the things that you want to do. I'm lazy when it comes to typing, especially a weird word like Teuthology. So I have this goofy little script that I put in my directory called T that passes all your arguments along and includes the Teuthology dash part. So I don't have to type that every time. But whatever. It also my path and the virtual env isn't, and so this sort of solves the problem of getting in my path. In any case, the thing in this case, I pushed a branch that is changing sort of the core OSD, and so I would want to run the Rados test suite against that in order to make sure that it passes all the tests. You'll remember that in the Git checkout for Ceph, there's this QA subdirectory. All of the stuff that Teuthology uses is in here. So tasks has a bunch of Python code that's used for running tests. There's code in here that sets up test clusters and runs workloads on it and so on. And then the suites directory is a collection of sort of piecing together those bits of code and to run a coherent set of tests. So for the Rados test suite, we have a bunch of sort of separate components. We'll look at the basic ones, so it's sort of the simplest. The idea here is that you can form a test matrix in each of these directories of all the different combinations of pieces of the test that you want to sort of combine into test cases. So in this case, this little magic % file that's in this top directory means that I want to form a matrix starting at this directory. And then all the subdirectories have sort of the different dimensions of that matrix. So I'll run the test on either Btrfs and XFS or XFS, and it'll build test cases that do both. I want to use different versions of the messenger, the simple messenger, async messenger, or a random one. I either will inject a few messenger failures or lots of them, and then I'll run one of these different workloads. And when you actually, in this case, this is like 10 odd things, and there are 2 here and 3 there and 2 there, and plus means it combines success. That's one case. So this is like for 12, this is like 100 tests right here if you multiply out all these dimensions. And so there's a whole combination of ways that these pieces can get assembled. And they're assembled in sort of alphanumeric order. So it'll go by sort the directories alphanumerically, and it'll piece these together. And all the pieces are just bits of YAML. So these specify some fragment of the overall test case and tasks, some fragment of the test case. It overrides some config variables and has some actual tasks that's going to run. So for each sort of combination of these pieces, you'll have a YAML that describes what the test is going to be, and then Teuthology will go schedule some nodes to go run it. And the tests can be put together in a bunch of different ways, but they usually have a tasks list, one step that says install Ceph or install the packages, which by default just installs Ceph. Ceph sets up a cluster on the nodes, and then this runs the scrub test, which maps to a Python script here that actually is the test case that gets run. So anyway, that's just sort of a very quick crash course on what Teuthology is. So if I want to schedule it, then I would do Teuthology suite. I'm using my little alias here. I'm going to run it on a particular Ceph branch, which is whip. I'm going to do one of the ones that Shaman actually, I'm just pretend that I'm doing whip sage testing, even though it didn't build. I won't actually run this command. I'm going to run the Rados suite. Because the test suite is so big, if you actually expand out all of those test cases, you get like 5,000 tests or something, and each one takes a half hour on 4 nodes. It would take days to run. So in practice, we run sort of a fraction of them. I usually do something out of 99. So it'll pick a subset of them, and then you can specify, that's mostly it. I can specify which machines to run it on, say Smithy. And I'll do dry run because I'm not actually going to do this.
This invocation is fairly magic for people that are not familiar with it, so don't expect to understand this going.
Yeah, I just want to give you sort of a flavor of what happens behind the scenes there. So this will, that package didn't build, so I'd have to specify a real branch. But assuming it did, this would schedule a whole pile of tests that'll get dumped in the queue and then will eventually get run. And then you can go look at the Pulpito tool, and you can see what actually gets run. So all this stuff is linked on ceph.com/code, by the way, that we looked at before. So the GitHub issue tracker, build status links to Shaman, where we saw these builds, which I was showing you before. And I guess Pulpito isn't linked. We should add that, Patrick.
All right, I'll get that up there.
Yep. Anyway, so Pulpito shows us all the QA runs. So this is who's scheduled to run, when it was scheduled, what test suite they're running, which branch they're running it on, which type of machines they're running on, and then it tells you how many jobs are queued, how many passed, failed, dead, waiting, running. So right now it's working on, the Smithy nodes are working on this FS test suite run on master that was scheduled by a cron job, it looks like. The Teuthology ones are the ones that run automatically. Earlier today I scheduled this one, looks like. But you can see. So if we look back a little ways, we can go look at an example of, let's see, we can look at my previous test run that I did yesterday, just as an example. So here I was testing a change in Blue Store. So most of the tests passed. If you look at any of these, any single test, you can see, that's kind of ugly here, but if you look at the log file that Teuthology generates, you can see the YAML file that describes what the test was right here. This is exactly what Teuthology was told to do. And then you have this huge log file that actually shows the test being run, packages getting installed, stuff being run, and so on. So you can see that it actually did what it was supposed to do. But I had a couple failures. So I'm going to click just to look at the failures, expand. Teuthology does its best to sort of pick out the salient error message out of the run. So I already did an analysis of these. It turns out that 2 of the pull requests that I had in my testing branch had bugs in it. The first pull request had one bug that made this fail. The other pull request had another bug that made Valgrind complain about a memory leak. And this one was another error that was related to infrastructure, I think. But in any case, what will generally happen is someone will batch up a bunch of pull requests. They'll run these tests. We'll go look at the results, make sure there are no failures, or if there are failures, that there are tickets open for them when we understand what the problem is. And if we're satisfied that everything's okay, the new code didn't break anything, then we'll go and actually finally merge the pull requests. That would be the next step, or the last step. And as an example, here's a pull request that I submitted earlier. It was like a really trivial change that moved, it changed this to this. And Igor reviewed it. So he approved the changes. It passed all the make check stuff. This was a simple enough change that it doesn't need to go through the full QA suite, although usually it would. But in that case, I would go through and I would merge the whole thing. And the one last thing I'll mention is that when we do these final merges, we put the reviewed bylines in here that say, who reviewed it. So there's a record in the Git history that indicates for every merge who reviewed the code that was part of that merge. Unfortunately, GitHub doesn't have a way to sort of do that automatically, so we do it somewhat manually.
So Stage, we are 10 minutes past here. I want to give people a chance to ask a few questions before we get too far into their day. But folks, if you have questions, feel free to type them in the chat or unmute yourself and speak up.
Hi, Sage. Quick question.
Hey.
Say you've done a pull request and you get a comment like, that's not correct, or can you take that bit off? What's the sort of process where you don't end up with like a million commits going, oh, that was wrong, this is wrong?
Yeah,
stuff like that?
a good question. Because particularly people who are new to Git don't always know what the right way to do is. So in this case, so let's say that pull request that I did before had a small error. I'm trying to remember what the branch name was. Whip Blue Store StatFS. Let me share my terminal here. So you would check out your branch. If you're sort of doing this in a tidy way, each change would be in its own branch, so it's easy to make these changes. I would go and change, make some change to the code to fix it, whatever. I want to do it differently. You can do git commit fixed thing, right? You changed it. But now your Git history looks ugly, right? You have your sort of original commit that looks all neat, and then you have this follow-on fix. And the way to deal with this is the magic of Git rebase, which has an interactive mode. So you can do Git rebase interactive on top of usually the master branch is what you're working off of. And this will take all of the commits that are in your branch and sort of list them here and let you do things with it. So you can reorder them if you want to rearrange the way that they're done. Or in this case, I want to take the small change that I made and just squash it into the original commit. And so you can either do F for squash and it'll just do it the whole thing, or if you do S, which is sort of the slow way of doing squash, then when it puts them together, it'll give you a chance to edit the commit message. You have to make some change or something here.
And just to interject for those people that have heard never rebase commits, this is cool because you're doing it on your own private branch, and so you're not screwing up anybody else's work. So the saving grace here is it's your own code.
Yep. And rebase is like the best thing ever. Git is a good tool for managing just patches. So in sort of old style of Linux kernel development, you have a patch series that you're working in and editing and so forth, and you're revising and so forth. You're doing the same thing here, you just happen to be keeping them in Git. The difference is that nobody else is really depending on your branch yet, so it's fine to do these rebases. So I've made the change, and then I can just re-push it back to GitHub under the same branch name. So the way to do that is git push, that's my remote name, and you add this force flag, because if I try to push it without the force flag, it's going to say it's rejected because it's not adding commits onto it. It actually has to effectively do a public rebase change of that commit of that branch. So force will just reset that branch to be exactly what you want it to be. And if you go back and you look at the pull request, GitHub will notice right away and update its thing. So that's the short version. So if I look at pull requests, you should be able to see it here. Yeah, there's the change I made, but I still have it in one nice tidy commit.
If I add a new feature and would need some iterations to get it up to the final shape, would you prefer a single patch, or is it okay to have a single commit, or is it better to have each of the refinement stages in a separate commit for the pull request?
It kind of depends. We do it both ways. So half the time, someone will do a code review and they'll say, change this and change that, and you'll sort of do the rebasing and squashing in your own branch and repush it again. If you think it's like basically ready, that's one way to do it. The other way to do it is to push commits that are on the top with like squash in the title that fix each individual issue. And then once everything's done and they've re-reviewed it and they can see the changes that you made and it's clear that you've sort of addressed the problems, at the very end, the last step would be to squash it down into a nice commit history. Either way, before we merge it into the tree, we want it to be sort of a clean series of changes without sort of fixes halfway through or at the end. But I think depending on the complexity of the change, sometimes it's nice to have that sort of intermediate step where you push the subsequent changes for review before squashing them in. If it's a simple change, then just squash them in. It's not that big a deal. It'll also work that way.
In my mind, the goal to aim for is by the time you're done and ready for the final push, have the commits make sense, have them tell a good story, have them be split up in the right way instead of, you don't want to record all your development history, you just want to have it compartmentalized the way it ought to be for understandability. Right.
And if you look at some of these, there's an example, like this has 6 commits and it's sort of, adding a new API, using the new API, implementing that API in one of the optional backends, fixing some sort of independent bugs. I think actually this commit got reordered up here and so on. So you want it to be sort of a set of logical changes, not like it works now, faster, that sort of thing.
All right, were there any other questions? Excellent. Okay, incredibly comprehensive. Right. Thank you, Sage.
Yeah.
And
thank you.
I'm sorry we ran a little bit over, folks, but I think this was very useful. And if you know people that were unable to attend, this will be up on the YouTube channel within the next day or two. So keep an eye out there. Other than that, we'll see you back here next month for a look at enabling fast big data analytics. The Alexio folks are doing a talk about some of their efforts around Ceph and big data analytics. So that should be interesting. We'll see you back here in a month. Thanks, everybody.